Today we will deploy a machine learning model on AWS SageMaker. Firstly, we will integrate our model to MLflow User Interface, then create two Docker containers. The first one will be a Docker desktop, while the second one placed on AWS ECR. From here we will deploy our model to AWS SageMaker, where all model artifacts will be saved to AWS S3. In the result, you can make prediction to your model as a regular user from a local terminal. So let's get started, and firstly we need to prepare Python virtual environment for that. Okay, so before creating a Python virtual environment for this tutorial, I want to tell you that for this I am using a Python 3.6, and then I will install MLflow version 1.0.0, and then I will use a Docker installed on my local machine. And overall I will use a Mac OS, and so let's get started. So we can create a Python virtual environment using conda, and I will use like this. I am typing a conda create and then double dashes name, and it will be, let's say, a deploy underscore ml. And for this I'm using as I said you before, 3.6 is a Python version. So let's press enter, and it's still creating. I agree with the conditions, press enter, and let's waiting to be created my virtual environment. Okay, it's being created successfully, so I can to activate it by typing a conda activate deploy underscore ml. So I can copy and paste. Okay, it is activated on the first terminal, and then I will activating it on the second terminal. So we have activated and created a Python virtual environment for our tutorial. And for the next step we will use two terminals. Here is the terminal number 1, and here is the terminal number 2. So if you are with me, so let's move forward. Okay, and now we are ready to install dependencies in our virtual environment, and let's start with the MLflow. So we install MLflow with pip install and then -q, it is quite MLflow, and I'm using a version 1.180 and it's 0. Okay, it's still waiting for being installed on my virtual environment, so let's just a couple of seconds to be installed. Okay, I see that case no errors, that's fine, and we can check if it's installed correctly. It is pip list, and where is our MLflow, and our MLflow is right here. So okay, it's created and it is correct, so we are ready to install pandas library. It is for open our train.py file. So pip install and pandas. The version doesn't matter, so okay, is being created. So and then I am using a scikit-learn library to make a prediction on our model, and of course to perform a training progress. So pip install scikit-learn and press enter. It's installing. Just wait a couple of seconds and it will be installed. Yeah, okay, we have installed it. The next step what we have installed in this moment is AWS command line tool, and it is very important to be installed in our tutorial because we will interact AWS by command line in our terminal. So it will be installed by pip install AWS CLI, and I will use upgrade function in here and user tag in the end of this command line. It is installing. Okay, looking nice. Okay, it's successfully installed AWS command line. Okay, and next I will install a Bota3 library. It also helps interact with AWS and this library will identify your user with between terminal and AWS console. Okay, let's install it. Let's install Bota 3. Okay, it's also being installed. You can check all your install libraries in pipe list in here, and I'm sure that everything is alright on my side, and so we are ready to move forward. It's a good time to create a new AWS user in this step, and for this let's go to IAM in AWS Management Console. So let's click on here, and in this window we need to select a user option right here, so click on this, and in user window we need to create a new one, and let's add user in here, and username, it will be my real name, it is Vytautas. So let's set your username as you want, it doesn't matter, but don't forget to use access type programmatic access. It's enabled an access key ID and secret access key for the AWS API, command line and SDK. It is very flexible option and exactly what we will need in this tutorial. So go to the permissions, and in the permission step we need to create a new group of policies. So let's create a group, and let's create a new group and set a name, for example, my user policies. So, and in policies I need to select two policies in this list. The first one is Amazon SageMaker full access. It is right here. Yeah, it is Amazon SageMaker full access. So I select the first one in here, and the next policy what I need for my user is Amazon EC2, and then container and registry, and it will be also full access. It is right here. So I selected also in my list, yeah, it is Amazon EC2 container registry full access. So I have two policies in my group, and I'm creating it right now. So yeah, as you can see, it is my user policies, and attached policies is this is the first one, and you can check the second one. It is for SageMaker. So okay, I see that everything is okay right now, so I go to the tags, and it is optional, so it is not necessary to fill it up. So I'm skip it and then go to the review, and as you can see, it is username is Vytautas, access type is programmatic access with an access key, and then no permissions boundary. Okay, it's work for us, and then my user policies group of policies is attached to my user. So I'm creating the user with these details, and it's very important step. You can see that it's success of creating your user. It is a username, and it is very important to just make a copy of your access key ID somewhere in your notes. Okay, for example, I am copying here, and then it is a secret access key. It is only one time you can to see it, and I suggest you to copy it and also put on your notes. You will use it in the next step in this tutorial, and this is very important to keep it safe. So I'm copy and paste it in my notes, and then I feel comfortable to close this guide to create my user. Okay, I see that so far is good, and now we need to set up AWS command line configuration. I hope that you are still enjoying this video, and now let's create a setup for AWS IAM user in our command line tool. So okay, and let's go to our terminal, and in here let's type an AWS configure, it is AWS and configure. Okay, and as you can see, you need to enter your credentials in this step. It is the first one is AWS Access Key ID, and remember AWS Access Key ID, it is from the what we have copied from the user interface. I'm copied right here, and then I need to use AWS secret access key. Remember I told you that you need to keep it safe, and then I copy and paste it in my terminal. Then I need to enter default region. My one is US East, the second one, so you should to check what is your. Let's go to the console, and for example mine is US East the second one. It is on the list from here, so let's check what is on your side. And I suggest to go to the main page of AWS Management Console and press here, and it is one that is highlighted, it is your. So let's type your region in the terminal, and let's use the second part of the name. Don't type the first part, what is in bold. You need to type the second part. In my case is US East and the second one. So okay, and I type it again to make it more clear, and yeah. Okay, and default output format, and I think the best option to use a JSON file, and let's write it as JSON. Okay, I see that the all credentials for my user is being entered, so do it on your side, and let's move forward. So, before doing all the following steps, we must be sure that if our freshly installed MLflow service is working fine on our local machine. To do it, type the following command in the terminal, and for this I am using not the first terminal that I used before, but for this I am using the second one. It is here, the lower one. So, and for this I am using the command MLflow and UI. It's meaning a user interface. It is a MLflow user interface. So, and press enter. And as you can see, this terminal shows some details about our MLflow service. And let's keep attention to listening at HTTP 127.0.0.1, and it's using a port of 5000. Let's use this address to enter to our MLflow service. So HTTP 127 and 0.0.1 and 5000. So let's enter. Okay, and you see the MLflow user interface. In here you should see experiment and models. So in this step we are sure that it's working fine, and that's what we expected to see, and we are ready to move forward. If you saw on the previous step, when we run MLflow UI command in our terminal, the new folder mlruns is being created in our project directory. So in this step we are going to adopt our Python script for MLflow, and as you can see right here, it is a very simple Python script which trains machine learning models for classification problem, and it's using a very simple iris dataset is to make more simple in this tutorial, and we can test it in the terminal how it's working in simple way. So let's write a Python and train.py. Okay, and we can see that the mean square error is 006, and technically it's working very good. So we are sure that we have a good dependencies in our virtual environment, and we are ready to make some correction in our code to make it more readable for MLflow. Okay, let's clear the screen right now and open the script again. I'm using Sublime Text. Okay, and it is very simple Python script, and we need to make some changes in here. So first of all, let's import MLflow, and as you can see in this example, we are using scikit-learn library to make a training of our model. So we should use MLflow and scikit-learn. It is a special functionality delivered by MLflow to perform scikit-learn model metrics. Okay, and what is more, we need to create a new experiment for training our model. It is MLflow, and then it is a special function set experiment, and let's say our experiment will be my classification model. Okay, and then we need to make some changes after splitting a training dataset in this position. So with MLflow start run, now we are defining the situation when we need to start a new experiment for training our model. So, and the run name will be, let's say, my model experiment. Sorry, my model experiment. Yeah, that's looking good. And we define is as name run. So with MLflow start run, we are initialization run, and the experiment name is my model experiment, and we define it as run variable in our code. And then we can to indent this part of our code and also make some changes. Okay, the first change is MLflow log param. Log param identifies which parameters in our model performance we want to track in MLflow User Interface. It will be user estimators. It is this parameter from our current machine learning model. We need to track in the MLflow interface, and not like this, but we need to use this kind of expression. The name of parameter is the num estimators, and we need to track this variable. Okay, the next thing what we need to do is after prediction we need to log the model performance. So MLflow scikit-learn, and we need to log a model, and the model is random forest, which is copy and paste right here, and the name of this model is random forest model. Simple like this. Okay, what is more, we can make a tracking of mean square error. Okay, MLflow log metric, not param but metric, and it will be MCA, the name of the metric we want to track, and MCA from this variable that is delivering the values. Okay, and after all of this we need to add some more lines. The first one is a run ID. That is very important, so keep in mind it. Run ID is getting from run info, then run W and ID. It is getting from our experiment, which we defined as run. We are using it right here. Run ID, then experiment ID. Experiment ID is equal to from run we use info and then experiment ID, like this one. Then we can to finish our experiment, so end run and brackets. And after this we can to just print some information. For example, artifacts UI, we will need to use it in the next step, so it's very beneficial to keep this information in the terminal or somewhere in your notes. So I like to print it out, maybe I will use it. So MLflow get artifacts UI and brackets. So I can to print also run ID. Run ID, and it will be equal to run ID from here. Okay, and if I don't forgot anything, I think I can save it. I think I made correct changes in my initial model code, so I think we can to make a test. So Python train.py. Let's see. Okay, I made some syntax error. Okay, it's coming from MLflow, and here and here and here and here. Okay, save it again, clear the screen. Okay, trying again. Okay, I see that it's working fine. It's very cool. And you see, okay, we can see from the beginning MCA is 0.067, artifacts UI is like this one, run ID is 52AA FA205. okay, and that's it, and that's what I exactly expected to see. Okay, and what I want to tell you is you need to just refresh your MLflow user interface, and look at the left side. In the list of your experiment, you can see that it is experiments, and this is your model. This is your experiment, my classification model. So if you go deeper in here, you should see 2 lines, and in the second row it is a run name. It's a my model experiment. This came from your Python script. It is your user, and this is a source Python code. It is train.py. This is the model that you use. It's a scikit-learn. Here is a parameter. You track the number of estimators. It's 100, and MSA, it is a mean square error, is 0067. So let's go deeper. You can see some very valuable information, like here it is some artifacts, it is a model itself with virtual environment parameters, where you can see a run ID, where you can see a creation time, and a lot of metadata. It is a special conda.yaml file defining your virtual environment, It is a model PKL, model itself file, a requirements file that defines the main libraries that you use in your training progress. So that's it for this part, and if you see the same on your side, it's very nice, so we can move forward from this point. So now we have very important part in our video tutorial. Now we are having a working Python script which is integrated into MLflow for tracking machine learning model parameters and to log some parameters. Now we are ready to create a Docker containers and push it into Docker desktop application and to AWS ECR, it is Elastic Container Registry. We need to create some tokens which allow us to communicate our terminal with AWS using our local machine, and for this we need to use a export command in our terminal. For example, we need to export variable. The first one is AWS access key ID, and this AWS access key ID is equal to what we have copied from the user account. It is mine. So, and the second variable that we need to create is export AWS secret access key. Remember when I told that you need to save your secret access key in your notes or somewhere, because it is very important, not a password, but it's like a token that you need to save for securely connection to AWS from your terminal. So this is mine. Remember, we have copied it when our user is being created at the beginning of this video. So now we have created these environment variables, and finally we are ready to create Docker containers and push it. Okay, so let's come back to our MLflow user interface, and in experiment you can see your experiment. This is mine. This is my classification model. So press here, and then you could see 2 lines or maybe more lines that is generated from your runs and experiments, and in here you should select this row that contains a model inside. In my case it is a scikit-learn, so I press on this row, and then if you scroll down you should see an artifact section. It is here, and just expand, and you should see some artifacts. It is a machine learning model information, it is a conda environment details, this is the model itself, this is the requirements for your environment. So, and if you go here you should see the full path to your artifacts directory. So if you go to your Explorer, it is ML runs folder, and as you can see now we have experiment number 1. It is 1, so the artifacts folder is 52AA FA205 and so on and so on. And remember, this full string is your run ID. It is right here. Next folder is artifacts that we will need, and then it is a random forest model. Let's go here, and from these files we will create a Docker container. Okay, let's activate our terminal and let's clear again. So now we are on the project directory, and this is ML runs folder. Okay, let's go to ML runs, then select folder number 1. Then remember we need 52AA FA, this is a run ID. So like this, and then we go to artifacts. Okay, and finally random forest model. And what files are inside this folder? It is the same files as you can see right here. It is on this list, and it is here on MLflow User Interface. It is the same file from different point of view. Okay, and now I'm sure that we are prepared to build and push container to Docker desktop application and to AWS ECR. So let's do. And for this I'm using MLflow functionality, then activate SageMaker option, and it is a very powerful command from SageMaker functionality. It is build and push container. Okay, press enter and let's wait a little bit. Okay, I see that the progress is on the way and it's creating, and login is successfully. So let's wait a couple of minutes. It can take approximately about 5 minutes. It depends on your internet connectivity to AWS, and just wait a little bit and then we will come back. Okay, and finally we got all image layers pushed successfully to AWS ECR and in Docker desktop application. So now we are ready to check for the status, and let's open a Docker desktop application, and in here we should see 2 lines of our images. The first one, as you can see, is dedicated for AWS ECR repository where our image is located, and the second one is MLflow PyFunc. It is Python function. It is our local image on desktop application. So now let's check what is going on AWS ECR. It is Elastic Container Registry. You can click on here, or you can try to find it from your service search. It is Elastic Container Registry. So let's click here, and you should see a MLflow PyFunc image that is created from your terminal from here. It is the same as you should see on your local environment, and this image is remotely connected with AWS ECR. Okay, and if you go here, you should see a image tag. It is a MLflow version. It is a 1.18.0. This is a MLflow version that we have installed on our Python virtual environment. So we can go here, and it is a main details about your image that could be deployed in AWS SageMaker, what we are going to do in the next steps. So I can close a Docker application right here. So, and see you on the next step. Okay, and now we almost on the finish line in our tutorial, and now we are ready to deploy our image from AWS ECR to AWS SageMaker. Okay, and we are ready to do it, and I just clear my screen from here, from this terminal, and just come back to my project directory. It is not right here, it is right here. Now we have a mlruns folder and train.py. I just come back on my Explorer in the same location. It is right here, and in here we should create a separate file. It is responsible for deploying our image to AWS SageMaker. So we are using a touch command in our terminal, and then we are creating a deploy.py. It is a Python script that will deploy our image from ECR to SageMaker. So I'm just creating it. It is right here, and now we need to write some Python script to do this action. So let's open this Python file with your Python code editor. I'm using a Sublime text, and here is it. So let's write our deployment code in this window, and first of all we need to import an MLflow, import MLflow and SageMaker as MFS. Okay, then what we will need, first of all experiment ID. Remember, it is the one, not it is the string, yeah. Okay, and then we need a run ID, and this is what is it, yeah, remember run ID is right here, the name of this folder. So I paste it, or you can find your run ID in here. So you can copy and paste it in your Python code. Then we also need a region, and remember we have a region of US East, and the second one, it came from right here, from the AWS itself. And then we will need AWS ID. Okay, leave it for later. Then we will need ARN. ARN is an, let's say, a remote connection with SageMaker IAM role, and we will create this role a little bit later for temporary usage, so I will leave it for later. And then what we'll need is application name, and application name is let's say is a model application. Then model URI, okay, it's equal to ML runs. Then okay, I think I will use a F string. After ML run, it is a experiment ID. Then it is a run ID, and then okay, this is artifacts, and then artifacts, yeah, random forest model. Okay, I think this is enough. So, and then tag ID. Remember, tag ID is from here. It is image tag, and we are using a MLflow version 1.18.0. This is our tag ID. Okay, copy and paste right here. It is a string. Okay, and what is more? So we can define our image URL, and it will be AWS ID plus .dkr.esr. It is the extension of ESR image container, yeah, and then plus region plus Amazon AWS.com. Okay, then MLflow and PyFunk, because we are using this name of the image. It is MLflow PyFunk. It is a Python function, is the stands for. Okay, and at the end we are using a tag ID. This is a format how we calling image URL. It is very important, so pay attention and be careful writing this line. Okay, Then we are using MLflow SageMaker, and with this MFS we are implementing a deployment. MFS, then deploy functionality. Okay, and what we are deploying, okay, first of all it is application name, then model URI equal model URI from what we have defined just before. Then we should define a region, name is a region. Then we should define what is the mode, and mode is create an application. Okay, next is execution role. Execution role from ARN, and this is what we will do a little bit later. In a few minutes we will create a new role for full access of SageMaker. It is for temporary usage, only dedicated for deployment purpose, so we will define an ARN a little bit later. Then image URL, and it's equal to image URL, and that's it. In this code we have some points what we need to fill it up. It is AWS ID and ARN for SageMaker full access IAM role, so we'll define it just right now. So in here I think we can start with more simple one, and I suggest to start with AWS ID, and you can get AWS ID in your terminal with very simple command. So I just clear the screen, and then let's try AWS STS, then get caller, then identity, then query, then account, and output is text. Okay, and here's it. Here's our AWS ID. We can make a copy from here and paste it here, and yeah, this is a string. Yeah, okay, that is look as we expected. Is so far so good. Now we should to create a ARN role for SageMaker full access. Is for temporary usage. Okay, then create a ARN for SageMaker full access. So, and let's go to AWS console, and here, so let's write IAM in this field, then go here in manage access to AWS roles, and then select roles in here. We need to create a new one, and it is here. Okay, and then we need to check what is the SageMaker, and here's it. Yeah, I think that's correct. Yeah, it's Amazon SageMaker full access, and it is correct one. This is what we need. So I go to tags. I skip it because it's optional. Okay, role name it's AWS SageMaker for deploy ML model. Okay, and we are creating the role. That's it. Okay, and here is it in the list of roles, and let's go inside, and this is what we need. This line, it is role ARN, so we need to simply copy, yeah, and then paste it in our Python code. So where's our Python code? Is here, and I just copy and paste. Yes, right here. So I save it. Okay, and one last thing what we have to do before deploying our container image from ECR to AWS SageMaker is to create a permission for our user to access S3 buckets. Okay, and let's go to the users, and then this is my user S3 tutas. Okay, and then I need to add some permissions. Here is it. No, and here I can to add inline policy from here. It is a service, and from the service list I'm looking for S3. Here is it, and I select the all actions, and then resources. On resources I select all resources to make it more simple, and review policy is the name of this policy. Let's say it will be a S3 full access for deploy. Okay, and creating a policy. Here's this in the list of my user policies, and this is what we need to deploy a model from ECR to AWS SageMaker and to save model artifacts on S3 bucket. Okay, I think that's correct, and we now need to run this deploy.py file, and let's do like this. And I think I forgot to check one thing. I just go back to my deploy script right here, and you see, just add this sign at the end, is double point. Okay, now it should be working fine. Okay, and let's try to do it. So we run deploy.py. Okay, let's wait and hope it will be success. Okay, and I see that it's finally getting successfully, and the full progress of this deployment was about 10 minutes, so don't be afraid for the long progress, and we can go directly into AWS and check what is going on. So first of all, I'm going to SageMaker. Okay, and then what I need to check is the inference, and in here go to the models. Yeah, okay, you should see it is deployed model. It's the model with name application model. Okay, if you go inside in here, we can see where exactly is the model location. As you can see, it is on S3. As I told you at the very beginning of this tutorial, the artifacts will be saved on the S3 bucket. It is a file that is containing these artifacts. And then let's go to endpoint configuration. Here's it. Here's some another data, also S3 location to be stored to data collection. So for example, if your model is collecting any kind of data, it will be stored on S3, and it's very good solution for this. So the endpoint, and the endpoint name is model application that we have defined in our deploy code, and it's works like this. If you go inside, we can see the type is real time and status is in service. That is perfect for us, and that's it what we need to check after deployment progress. So now we are ready to go to the next step. Okay, and now we on the finish line in our video tutorial, and I just clear the terminal window and come back in the main working directory in here. And what I need to do right now is to create another file, is predict.py, and with this file I will make a new prediction using a deployed model on SageMaker. So here's the file that I being created in seconds. and I need to write some additional code in here that will make connection to AWS SageMaker and make a new prediction with the data I ingest into the model. Okay, don't worry about the script, you can find this in the repo I will provide in the description of this video tutorial. And okay, I just need to add one bracket right here. Okay, and with this script I can make a prediction by ingesting a new data into the deployed model on SageMaker. And I made the script very quickly in straightforward way. You can make it differently, but the main idea of this script is make communication with AWS SageMaker model with both of three. It uses region, application name, and it can ingest a new data into the model and return a prediction from the model. So to make it more simple, we can print the query, and you can see which data we are ingesting. Okay, and we can make a prediction right here. Just run the script Python and predict. Okay, I see that the application status is in service, and we ingesting this data, and received response is 0. Okay, what if we change the data we want to ingest? It was 12, now I change it to 3. That means row is 3 of data. You see? Here's a different data, and the response is 1.99. Okay, and the last test, let's say I want to ingest 15. Yeah, just save it. Let's try the new test. Okay, it is a new data, and the new response is 1.0. Okay, I think you got the main idea of how it's working, and congratulations, we've finished this tutorial. And the next step is the bonus that I provide you to deep dive into this tutorial. So again, congratulations, we finished this tutorial. It was not easy one, and as the bonus for you, I suggest to check this repo that I made especially for you. You can check all the steps that I explained in this tutorial. It's about 1 hour length, and it is everything in one place with all details, nothing missed, and you can check it on your site and do it on your any application as you want. This is what I made especially for you, and if you find that something is missed or you need to add some clarification on any step, just let me know and I will do it. And that's all from my side today, and see you on the next video. Never stop learning, and thank you for watching.